All right, let's talk chips. When we talk about computer chips, it's so easy to get bogged down in the specs, gigahertz, core counts, all that stuff. But the real story, the one that's actually shaping everything from the phone in your pocket to the whole AI revolution, it's way more interesting. It's really a story about three completely different ideas.
So, have you ever really stopped to think about what separates, say, a monster Nvidia graphics card from the chip in your iPhone or the one inside a new Android phone? Because the answer, it goes so much deeper than just asking which one is faster. See, it's not just about speed. It's a fundamental battle of ideas, of competing philosophies. Each of these companies is basically trying to solve a totally different problem. And the way they're doing it, well, it's created three really distinct paths for where computing is headed.
All right, so here's what we're going to get into. We're going to break down these three big ideas. First up, the philosophy of raw power. Then we'll look at the philosophy of total integration. And finally, we'll unpack the philosophy of absolute control.
Okay, so first things first, we've got to be clear that we're not really comparing apples to apples here. Nvidia, they're mostly making what we call discrete GPUs. Think of those big, powerful graphics cards you'd plug into a gaming PC. But Apple and Qualcomm, they're doing something different. They make entire systems on a chip, or SoCs. That's basically a whole computer squished onto one tiny piece of silicon. And then you've got ARM's Mali, which is a bit different again. It's like a GPU blueprint that other companies can license and build into their own chips.
So, to really get to the heart of what makes them all so different, we need to do something. We need to look past all the marketing fluff and focus on the core goals. What are these engineers actually trying to achieve?
All right, first up, Nvidia. This is what I'm calling the power philosophy. Their whole game is about one thing: maximum throughput.
And this quote? This just says it all, doesn't it? The wall socket provides infinite power. Use it. That perfectly captures their whole mindset. For Nvidia, especially when you're talking about massive data centers or top-of-the-line gaming rigs, the enemy isn't a battery. The only thing holding them back is the laws of physics. Their one and only goal is to crunch as many numbers as inhumanly fast as possible.
And wow, this chart really shows you what that means in the real world. Just look at the power draw. A high-end Nvidia GPU can chug over 600, even 700 watts. That's more than 10 times what a super powerful Apple laptop chip needs, and it's almost 100 times more than a Qualcomm chip in a phone. It is pure and simple, a brute force approach to performance.
So, okay, what are the trade-offs here? Well, the upside is pretty obvious. You get absolutely unbeatable performance for things like training giant AI models or playing the latest games in stunning 4K. But the downside? Well, they're incredibly power-hungry, they cost a ton, and they lock developers into their own software system called CUDA. So, where do they really shine? In places where power is basically unlimited. Massive data centers and serious gaming PCs.
Okay, let's pivot to our second philosophy. Now we're talking Qualcomm and ARM. This is the integration philosophy. And for them, the world looks completely different. Their world is defined by two things: a tiny battery and the absolute need to always be connected.
The best way to think about their flagship Snapdragon chip is like the ultimate Swiss Army knife. Seriously, it's not just one tool. It's a whole toolbox on a single tiny chip. It's designed to do everything your phone needs, right? It's got the brains for general computing, the muscle for graphics, a special part for making your photos look amazing, an AI engine, and maybe most importantly, a world-class 5G modem. And it has to do all of that without killing your battery before lunch.
And when you actually look inside a Snapdragon, it's just wild. You see all these specialized little engines all working together. You've got your main CPU, sure, and the Adreno GPU for games, but then there's the Hexagon processor, which is built just for running AI stuff efficiently, and the Spectra processor, which is all about making your photos pop, and of course, that modem for that sweet, sweet 5G. Jamming all of that onto one chip without it literally melting, that is a straight-up engineering masterpiece.
So what's the bottom line? Their biggest strength is that incredible integration, that perfect balance of performance and battery life. The trade-off, though, is heat. A little phone just can't get rid of heat like a big desktop PC can. So when it gets too hot, the chip has to throttle down. It has to slow itself down to avoid cooking itself. It's a philosophy that completely dominates the Android world, and now they're making a huge push into Windows laptops too.
And that, of course, brings us to our third and final philosophy, Apple. This is the control philosophy, and this is where things get, well, really, really unique. Because with Apple, They don't just make the chip. They make the hardware, they make the software, they make the entire thing.
So if Nvidia is all about raw power and Qualcomm is all about integration, Apple's mission is something else entirely. Their goal is to hunt down and eliminate every single bottleneck in the system. They're not just trying to build a fast chip, they're trying to build the most brutally efficient system by making sure every single piece of the puzzle works together in perfect harmony.
And this right here is their secret sauce. It's called unified memory. Okay, think about it like this. In a regular PC, the CPU and the GPU are kind of like two different chefs working in two separate kitchens. If the graphics chef needs something from the main chef's kitchen, someone has to literally run it across the building. It's slow, it's a waste of energy. What Apple did was put all the chefs, the CPU, the GPU, the AI engine, they put them all in the same kitchen with one giant pool of ingredients right in the middle that they can all access instantly. There's no copying data back and forth. It's what's called a zero-copy approach, and it is just insanely efficient. It saves power and cuts down on lag, or what engineers call latency.
And having that much control is what gives them that legendary performance per watt. It's the reason why a MacBook can chew through a 4K video edit on battery power just as fast as when it's plugged into the wall. Now, what's the catch? Well, it's a totally locked-down closed ecosystem. You can't upgrade that unified memory later, and you're only ever going to find these chips inside an Apple product. Period. So we've looked at all three. The big question is, which philosophy actually wins? Is it power, integration, or control?
You know, this table really just nails it. Nvidia's power philosophy, it's a top fuel dragster. Absolutely unbeatable for a quarter-mile race, but you're not taking it to go get groceries. Qualcomm's integration philosophy is that perfect Swiss Army knife. It has a tool for every job, it's super versatile, and fits right in your pocket. And then there's Apple's control philosophy. That's a Formula One car. Every single component is custom-built and fine-tuned to work in perfect harmony, all for the sake of ultimate performance and efficiency. So in the end, there isn't one single best chip. It just doesn't exist. The actual best chip is the one that was designed from the ground up to solve one specific problem really, really well. Whether that's training a mind-bendingly huge AI model, keeping 1 billion smartphones online, or letting you edit a feature film on a laptop in a coffee shop. And that really leaves us with a huge, fascinating question for the future. Right now, powerful AI mostly lives in the cloud on giant racks of Nvidia servers. But as that AI starts to move from the cloud and directly onto the device in your pocket, which of these philosophies is going to matter most? Will we need the raw power, the seamless integration, or that total system control? Honestly, the answer to that question is probably going to define the next decade of our lives.